All right, happy Monday. We are moving along here in content. We're more than halfway done with content, actually. Right, we've got chapter 8, so that's the first 8 chapters is the core, everything we want to get into Python. And then we do a little bit of classes. We'll get deeper next semester into classes. We do a little bit with exceptions and modules. We can do more with that later on. We'll do a little bit with files. We'll get Thanksgiving break off, and we'll do a little bit of a lot of things for this last week with inheritance. Again, it's a big topic for next semester. Recursion is a big topic for next semester. And then just some fun stuff, Python for data science, just to show you, hey, here's the tip of the iceberg before we get further into that. So in terms of like new content weeks, we got 4 more weeks of content after this week, right? With 8 weeks down and 4 left. So 2/3 of the way through with content, believe it or not. Next Monday, we got the project due. We'll talk about the project. We'll do our midterm review. And then on Wednesday the 30th, I will open the midterm exam. You're welcome to come and sit and take it if you want at 12:30, or you're welcome to click start on it at any point in time up until 10 or 11:04. Right? Whenever you want to take it is great. I don't particularly care to watch people take tests, especially if they're open book, open notes. Please use PyCharm, right, for the coding questions. Don't type code into Canvas and just hope it works. Use PyCharm and then just copy paste. Life is pretty good that way. Some people give coding exams on paper, and it really hurts my head. It hurts my head. And they even you had to write stuff down. Okay, I don't know. But I don't believe in that, so I don't have to do it, which is kind of cool. So that's the plan for the midterm. Again, I'll give you last year's, I'll rewrite it. It's 15 short quizzes style questions. I like true-false questions, but if it's false, you have to correct the statement. I think that's much more interesting than just true or false, or fill-in-the-blank style. I don't do any multiple choice because I think those are dumb. And then 3 coding questions. Hey, here's a question to do this. Again, they're short. Ideally, it's meant for you to take about 10 minutes per coding question. So if it took you 20, double that amount of time, and then all the short answer questions, you could get it done in an hour 15 if I wanted to sit and watch you take it. That's the goal for how long it should take. Sure. Yeah.
I forgot if you said it was time.
No, I'm not going to put a time on it. It's not worth it. So just, you can even save it and come back to it if you really want. That's fine too. Yeah.
And it's open notes?
Yeah. Does not open Neighbor, right? Use your textbook, use the internet. If you can find the answer to my question online, so not ChatGPT. That one doesn't count. But again, it's the answers will be like a paragraph. So there's really nothing you can even cite for without it being an entire quotation, and you just can't turn in an entire quotation, right? Because that's just too much, right? Just like an English paper. You wouldn't give back, hey, here's my essay question answer, one giant quote, right? So I think the same philosophy will apply for this. And if you got questions, let me know, right? You won't have to hit submit until 11:04, so you're welcome to ask me anytime. All right, so we'll get into chapter 8. A little bit more on the Zybooks here. That's getting better. It's getting there. Again, you'll want to spend the time on it. Ideally, you're doing it the same week we're talking about stuff so that you're getting all your practice in that week. Repetition and repetition and repetition really does help you learn. Talk to anybody who does brain science stuff. They're really smart people. But you've got to do it more than once, right? All right, so let's jump into lists and dictionaries. I'll fire up PyCharm here. So this is going a little deeper with lists here, and a little deeper with dictionaries. So it's kind of a large section, but that's okay. We got today and we got Wednesday to work on it here. So we've done some with lists before. It's a way I can throw a bunch of things in it. It's a container, right? The order matters, and it's mutable. I can change it here. So I can put things in and I can change them as I go. We access things by index. We go through that. We always start at 0 because that's how everyone counts. We always say 0, 1, 2, 3, 4 because normal people count like that. And then you can slice it. We spend a lot of time slicing, right? We sliced strings. You can also slice lists, right? So we can do some cool stuff with that. You can add lists together. Sure, it just concatenates them, kind of like it does with a string, right? Because strings are almost like lists. And then you can use this delete keyword. I'm not super fond of the delete keyword to say delete this. I much prefer pop. So that removes a given item here when we go. Yeah. All right, all the fun things you can do with lists. Let me start a new chapter here. New project. This is chapter 8. Lists and dictionaries. All right, cool. I think I spelled that close. Maybe. It's a Monday, even for the computer. All right. So we've appended is the most often thing we've done. Extend is just like adding, right? This list plus this list, but you can call dot extend if you want to be fancy here. And then insert is really interesting. You can put something at a given index. Say, hey, I want this to be the new first thing, or I want this to be the new 7th thing, or I want this to be the new index 3. Here's the value here. So those are fun. To remove items, you can remove a value, or you can pop something off the end, or you can pop a given index. Much prefer this to delete here. So if I make a list of foods, it's always foods here because I'm hungry. Actually, I ate Chipotle on the way. It was really good. So I'm actually not hungry. I probably shouldn't have eaten the whole burrito. But by the time you get down to like the last little bit, you're like, do you really want to wrap this up? That's fine. So we had rice, we had beans, we had veggies. What was it? The corn something or other, corn salsa. I forget what they call it here. And the green salsa. I'm terrible at names here. I just go by colors. All right. So this is the ingredients maybe? Ingredients. So you can remove things or you can add things, right? So if I wanted to take something off here, because maybe you don't want the corn salsa on your burrito here. So we could take our ingredients, and I could either call remove and give it this value here, right? Or I could take ingredients and I could say I want to pop, hey, let's take off maybe the veggies. So that's at index 2. So we don't want just rice and beans and green salsa. So let's pop index 2, and we can print ingredients. Right? So this removes by value, this removes by index. And we should get just rice, beans, and green salsa. Super exciting. Oh, the guacamole. I can't spell that, so I'm just going to go with guac, right? Because that's probably close enough. There we go. So rice, beans, green salsa, and the guac. And life is good. We get our good, tasty burrito, right? So you can remove things by name, by index. Super handy way to go about it here. You can sort a list if you want. The list.sort will sort them in place. So there's slightly different here. So this will change your list to make it be in sorted order. So I can take ingredients.sort and I can print ingredients here. And now we'll get the sorted order for this. Beans, green salsa, guac, rice. And of course it sorts, checking first letter at a time, right? Converting these to numeric values and seeing which one is the smallest. Just so happens to also sort alphabetically. It just kind of works out really nice for us that way, right? So we get an alphabetic sort, right? Now, uppercase and lowercase kind of screws this thing up though, right? So let's leave beans in here with a capital B. And now beans is first because the capital letters have a lower value than the lowercase values, right? Remember we looked at that Unicode table? We take the ordinal values of things. So just be a little careful with that when you go through. So that it's sorted, changes your list. If you want, you could get a copy of your list in sorted order. This is before we sort then. We'll do sorted ingredients. Is you say sorted and you give it a list here. So that sorted is a function. You can give a list. It will sort and give you back a copy, right? So it won't change the original ingredients list here. So if I want to, instead of sorting here, we'll just print the sorted ingredients. And we can print regular ingredients. Right, so it doesn't change the original. So if you want the original changed, great. If you don't want the original changed, then we can use sorted, right? Or you could make a copy of it with slicing. Remember, slicing will give you a copy essentially. So you could get another sorted is my ingredients list sliced from the beginning to the end dot sort. And we can print another sorted list here. And we should have, nope, my bad. This sorted it, but didn't, what happened here? It didn't save it. That's right, this doesn't return anything. Dot sort. Ingredients dot sort, Why didn't it save it here? So that'll sort the copy. Yeah, we're still getting a none here. Our sorted is, just say it's a list. Wow, I've not tried that in a little while here. Thought that would have worked. Nope. It's giving me none back. Dot sort. Oh, okay. So things happen in the right order of operations. Right, so this thing happens first, and then sort happens on it. So this is a list, which is a copy. Then when you call dot sort doesn't return any values. It's a function, but has no return type. It just gives nothing back. So that's why that was being set to none. So I need to make a copy of the list, and then I can call sort on that here, because this will stick around here. Then I should be able to print it out. There we go. Now I get another version of it sorted here. Because doing the slicing will make a new list, but just calling dot sort doesn't return any values here. So if I say like print this, I'm going to get a none back out. Or if you hover over, it should tell us with sort here. This last little arrow none right here is saying, hey, it's not going to return anything. It returns none. So you can't save the result of sort here. So I was running into that. All right. So a couple ways we can get our list sorted here, just some fun things. You can get the index of a given value. We did that. You can get the count of a given thing. I think we did this mostly with strings. Hey, it works the same with lists. Find me this here. And if it does not exist, right, so if you want the index of, it's my ingredients.index of chicken, we're not going to find chicken on my burrito here. Uh-oh. Value error, chicken's not in the list. So it doesn't, with .index, I don't even get back like the -1, like when I was trying to find a value here, I get an error and it crashes. So this is not a great way to get the index back. So you'd want to check to say, hey, if chicken is in my ingredients, then I can go find, hey, what its index is to avoid from crashing here. So index will error and crash. Value isn't present. So check for it first, right? Count should be fine. I think we should be able to get a count out if it doesn't exist pretty easily here. So we should be able to print ingredients.count for chicken. And we should get back 0. So you could also check if count is 0, but this is probably a little bit easier to write here as well. Okay, so there's some fun things we can do with lists, more practice with lists. Looping over lists, we've done a lot of iterating over lists, right? For value in list, that's the quick, easy way to do it. We've done for indexes in range, the length of the list, which makes it easier to modify, right? If we do this kind of loop, it's like read only, essentially. We're getting copies of the values here. So we'll repeat that one here. So for ingredient in ingredients, print the ingredient here, right? And this is getting copy of each, so read only essentially. This will change slightly once we get a little further in, but for now it's a pretty good rule of thumb. And then we can say for index in range, the length of my ingredients here, and now I can go through and get my ingredients at the index, and I can do something with it here. So I can modify them, modify the list at a given index. Right, so it's not getting a copy each time. We're just saying, give me the item inside the list, right? Referencing that one directly here, rather than getting that copy back out. So we can loop through them that way. Max numbers, sure. You can use enumerate to do both. Did we do this before? I think we did that where we got both values. So we could say for index, comma, ingredient, in enumerate the ingredients list. Ingredients list. Now I can print, we'll do a formatted string, we'll say here's the index, and here's the colon, the ingredient. Right, so it gives you a way to get them both out at once here, which is nice. So you can see, hey, here's 0, 1, 2, and 3. So if you have menus or something, that's a really nice way. Hey, enter 0 for this, 1 for this, 2 for this, that sort of thing. And we can go by index. That's pretty handy. Anytime you need both, right? We can get both out this way, but I just have to do the same thing here. I do a formatted string. Let's say, hey, here's the index, and here's the ingredients at that index, right? we'll do the exact same thing, but this is slightly more typing, I guess. Maybe, maybe not, than using enumerate. Just a style preference, whichever one you like here. Oh, I forgot my colon. Gotta make that look pretty. All right, other functions, right? All checks if they're all true. It's sometimes useful. You got to find some special cases for that. If anything is true, you got to find some special cases. Max, min, and sum are pretty handy if you've got numeric values. Max of a word list is not all that interesting, but sure, you can get the letter with the closest to Z starting, or the word with the closest to Z starting first letter, right? It's essentially giving you the last value once you sort it. Or if you sort it for min, you'll get the first value. When you sort that, sum is really handy. A lot of built-in functions with that as well. And some games and lists. Oh yay, those are fun. Here's where it gets crazy now. Right? Because lists can have things inside of them, right? You can put a list inside of a list. Right? So if I wanted to build out a little tic-tac-toe board here, I'm going to make my board. We'll say, here's a list, and I'm going to say, hey, the first row is, here's a space, here's a space, here's a space, comma. So this is the first item in my list called board. It's another list. Right? And then the second item is another list, and the third item is another list here as we go. So now I have 3 rows with 3 spaces each, a nice little tic-tac-toe board. Right? So I could say, if I print the board, it's going to look a little ugly here. It doesn't give them all new lines, right? It says, here's your first item, here's your next item, here's your next item. So if we want to print it and make it look a little bit nicer here, we'd say, for row in board, right? Essentially, it's the row, right? And then the individual items inside of that are columns. Then I'm going to print the row. Now remember, print automatically gives me new lines, so right off the bat, this should be a little bit prettier now. I get this. Still not the prettiest looking thing, right? It doesn't really look like a tic-tac-toe board, right? So what if I want to make it look like a tic-tac-toe board? Well, I could do that. Well, what I want to do is I want to take the pipe character here, because that's like a straight up and down line. That's the shift backslash here. And I'm going to call join on the row, right? Remember, we could take a string and join a bunch of things together with it here. So that'll print the straight, oh, sorry, we're going to print that. So it'll print the straight up and down lines here. But now I need my horizontal line. So I'm going to do that once, and then I'm going to print a bunch of dashes here. I think it's 6, right? Space, dash, or line, space, space. No, okay, so just 5. Only 5. I can count, right? Oh, yeah, that's pretty close, but we don't need the last one here, right? We only really need 2 in between here. Okay, Well, what if I want to take this? I want to join these other ones together. That's going to be really messy, isn't it? I don't know if I can do that. You can, it'll just get really ugly looking. Let's say for index and row and enumerate the board. If my index does not equal 2, let's print this. If it is 2, if it's the last row, index 2, I don't want another line afterwards. That's probably a quick way here. Right, so we'll get it for index 0, the first row. We get the row, we get a straight line. Index 1, we get the second row, we get a line. Index 2, we get this one here. Right? All right, cool. So this one prints it out here. So let's take all of this here. Let's turn that into a little function here. So I'm going to go refactor. I'm going to say extract method here. This will be print board. And we can add a parameter. Shoot, that's fine. We can call print board, but I really want it to be given the board. I don't want this global index nonsense. No thanks. So if you give me a board, I'll print the board here. So we can call print board. So we'll make a board, and we can call print board. Our function needs to be up above, so Python knows all about it here. Let's throw this up at the top. Here we go. So we should be able to print a board, given a board. Let's see if it prints. Hey, it prints out. Okay. So now we got a nice little tic-tac-toe board. So now we want to have somebody play the game, right? So if we think about how we want to take tic-tac-toe, and break it down into smaller and smaller and smaller and smaller pieces. Right? Printing the board is one of those small pieces. We got that one already here, just trying to do it. So getting someone to tell me where they want to place their piece is important, and also making sure they're not trying to place it on top of someone else's piece. And that's probably part of that same problem here, right? So we want to like get the location. That's what the row and the column maybe here, or maybe just place a mark on the board. Maybe we could say that. So place mark on the board, and we probably need to know who the current player is too, right? To know which player we're putting there. So we'll say current player. So I think the current player will probably start as X's, right? Does X usually start? Right? Okay, so we'll have X start. So we'll go place a mark on a board. Here's the current player. Right? And then we'll come back, we'll flush all this out when we get here. So we'll place a mark, and then, or really like while they're not is game over, given the board. So if I look at a board, I can figure out whether or not the game's over or not, right? Pretty quick. So we'll say not the game is over. We want to keep on going here. We'll place a mark for the current player. And then we want to change the player's turn, right? So we'll say my current player then, well, if they were X, right? So maybe if current player is equal to X, then my current player will equal Y, or no, O's. There we go, X's and O's. Otherwise, current player becomes X. Now this one's fun for one of those ternary expressions, right? Those little one-liners for an if-else here. And they're really awkward to read sometimes here, but we could say, hey, current player is going to equal X if current player equals O, else O. I think something like this. And like just reading that is just awful. Remember, these are just terrible. I mean, I don't like these things here. But cute, it's in one line instead of 3 or 4. So some people like them a lot. But just because it reads so backwards, it's so weird here. All right, cool. So we'll place a mark, and then we'll flip the player's turn here, and then the next player places a mark. If the game's not over, next player places a mark. If the game's not over, next player places a mark, right? Eventually, the game will be over, and then we're done, right? Not super complicated here for tic-tac-toe, right? How about let's do is game over? Does that one sound fun? That's pretty easy to check here, right? So define is game over given a board here. Now, we could find out who wins here, or we could just say the game is over, yes or no. Right? It's probably easier to just say the game is over. Works out pretty well. So the game is over in a couple different ways in tic-tac-toe, right? Either you've gotten a complete row, you've gotten a complete column, or you've gotten a diagonal, or there's no more place to go and nobody has won, right? So we need to see, all right, the game is over if somebody won horizontally, or the game is over if someone won vertically, or the game is over if someone won diagonally, or the game is over if there's no more spaces, right? So we can check all those things. So it's pretty easy to check to see each of those here. So we're going to return, did someone win horizontally, given the board, or did someone win vertically, given the board? Right, we're doing our functional decomposition here, breaking it down into smaller and smaller and smaller pieces here, right? Vertically, I think I have to do the slash here, right? Or did someone win diagonally, or no spaces left? Oh, that's a cat's game, right? I don't know why, but I think that's fun to say, given the board. Right, cat's game, that's a thing, right? Okay, right, if there's no spaces left. I don't know who came up with that, but apparently if you make your own game, you can do stuff like that. Now we need to write a bunch of functions, right? So here's a big function, is the game over? We're gonna break that down. I can break it down into smaller pieces. There's still a simpler thing to do, one step at a time here. So we're gonna define all of these ones here then. So we can define, did someone win horizontally? Oh, I spelled it wrong. Horizontally. There we go. I'll move that T over here. Spelling doesn't actually really matter too much here, but that's okay. Did someone win vertically, given the board? We'll define that one. Did someone win diagonally? Define this one. Oops, gotta say define, give a little colon, go back a little bit. go down a line, almost there, and define cat's game given the board here. Okay, so horizontally is pretty easy here. We're going to check and see, do all three spaces match? Right? I don't care if they're X's or O's, I just care do all three match here. Right? So for each row in the board, if the row at 0 does not equal a space, right? Because spaces, if all three spaces match, nobody won still, right? So it can't be a space, right? So if it's not a space, right, and row of 0 is equal to row of 1, and row of 0, index of 0, is equal to row at index 2. Right? For each row on the board, if it's not a space, and the first matches the second, and the first matches the third, then I can return true. Somebody won. Right? If I go through every row on the board and I haven't returned true yet, then I can return false. Nobody won horizontally. Right? Because if I didn't find a winner at the first row, the second row, or the third row, index 0, index 1, index 2, nobody won horizontally. Right? Same idea here with vertically, but now it's a little bit different. I can't look at every row in the board, right? Because I have to go by column. I want to look at the first row, column 0, the second row, column 0, the third row, column 0. Right? So really I want for column index in range length of the board, right? That ought to be close here. And then if now my board at 0, right, because I need to look at the first row every time no matter what, okay? Now with a list of lists, this is where it gets messy here, right? Because the board at 0 is the first row, which is another list. So at the column index here, right? So if you have a two-dimensional list, it's the row index first and then the column index. You can specify, right? Because row 0 is the first row I got back out here, right? That's this one here. And then column index, so I'm going to check 0, I'm going to check 1, and then I'm going to check 2. Right? So if that one does not equal a space, right, and this one matches the next one here, is equal to row 1 at the same column, right? And the board at 1, I'm sorry, board at 0 is equal to the board at 2 at the second row at the column index. That got a little long here, shoot. Okay, so we'll do this. It's not that one, and I need these backslashes. Those are annoying sometimes here. I think you like extra tab it in or something. Now it's saying I don't need it? Okay, sure, unnecessary. That's fine. So if it's the first row for the given column, 0, 1, or 2, is not a space, and the first row at the given column matches the second row at the given column, and the first row matches the second row at the given column. Or third row at the same column here. We'll return true, because we found, hey, we found a column here. Right? Right? Diagonal now, this one you probably don't even need all this extra work here, because it's only just 3 things here. This one's not going to be quite as hard. And pretty quick I can check to see if my board at 1, 1, that's the center, right? Row 1, column 1 is the center, right? So if that one is not a space, and board at 1, 1 is equal to board at 0, 0, right? So that's the top left is 0, 0, 1, 1, and then we're going to go down to 2, 2, right? And board at 1, 1 is equal to board at 2, 2, right? That's a win, right? Or, right, I have to be a little careful here, right? So this one is, those ones match, right? Or the other diagonal now, right? I could have my board at row 0, column 2, right? That's the top right here. First row all the way to the right here, top right, is equal to my board at 1, 1, 1, 1, and my board at then row 2, column 0, bottom left, right, is equal to board at 1, 1. Right? If either one of these is true, right, so it's not a space, and then it matches these corners or it matches these corners, right? Then I can return true. Now with this one, if I'm just saying if something's true, return true, else return false. This is a big pet peeve of mine here, just because I'm cranky sometimes, right? You're saying if true, return true, else return false. You can skip some lines here and just say return, right? Because it's either true or false already. Right? With these ones, we needed to check because we have to check all 3 rows. I can't return the true or false immediately because it wouldn't check the next 2 columns or it wouldn't check the next 2 rows. But this is just, this whole thing here is either true or false right off the bat here. And then for cat's game, right, we need to see, did we find a space? Right? So for row in board, if there's a space in the row, return false. If we go through all 3 rows and we haven't found a space, I can return true. It's a cat's game. Right? That's pretty quick. We can use our little in operator and check. Okay, so let's see. So, oh, I missed an or here. Or. There we go. So if the game is over, if someone won horizontally, or someone won vertically, or someone won diagonally, or it's a cat's game, the game is over. Now, I'm not telling you who won or lost here. Most people can look at a tic-tac-toe board, and if you tell them the game's over, they'll know what happened. Right? Even my 3-year-old can do that. Right? That's not that hard. So I think that's okay. And that would just make more work for us here. Right? So then the last thing we have to do is place a mark. Right? So here's the board. Here's the current player. Let's place a mark on the board here. Right? So we'll do place mark. Define place mark, given the board and the current player. Okay? So to place the mark, we probably want to print the board for them, right? And tell them here's the board, right? So we can actually skip this one here, which is nice. So we'll print the board, or print board, given the board. Oh goodness, there we go. And then I'll tell them here we'll print, current player's turn. Current player's turn. And now we need to get the row and the column. So I can have them type it in on a single line, or I can have them type it in separately. Totally up to however we want them to type it in here. It can work, right? What do you think is easier, doing 1 input or 2? Just 1? Okay. So we'll say we'll have a row and column. Then we'll equal an input of, please enter the row and column you want to mark. Okay? Now here's where it gets tricky though, because now I need to take that and split it up here. So we're probably going to tell them like something like, we want like 1, 1, right, as an example, or 2, 2, or something here. So if I know it's a number, space, a number, I can split those up here, right? So then I can get the value here. So my row then should be my row and column dot split, right? And I want the first thing here, and then my column should be the row and column dot split the second thing. Right? I should be able to get those out. Right, by splitting it here. Cool. So now I've got those, but really I need them as integers. Right? So I really need an int of that. Because to use index notation, it has to be an integer value. You can't say index of quote the character 1. It has to be quote the integer 1, right? To get a given value out here. Right? Now we need to see if that's valid. Right? If that's not taken. So I can check if my maybe we want while my board at the row at the column is equal to a space. Right? If they gave me locations and there's a space there, I'm sorry, if it's not a space there, if it's an extra row there, if it's not a space, it's not good. I want to ask them again here, right? We'll print like there's already a mark there. Try again. And maybe we just do the row and column here. Maybe we don't have to print the whole board out, right? Please enter row and column to mark, right? Then when we're done, I need to give back that row and column, right? So I'm going to return row, comma, column, right? It'll automatically pack those into a tuple for me, tuple, if you like. So then getting their mark here then, oh, I'm sorry, the place, okay, no, that's right. I didn't even have to return it. I can just place the mark. I forgot. Once we're done with that, then we'll take the board at the row, at the column, and we'll assign it, right? We're going to change the value there to the current player. That's right. This makes life even easier. I don't have to give it back, right? Eventually we'll get something that is a space, and I can mark it here, Right? It'll be valid. Now we can do some other checks and make sure they don't give me numbers less than 0 or more than 2, or there's other sanity checks we can do here because people are going to be bad at tic-tac-toe and nobody counts at 0 because they're not smart enough like we are, right? I've not tried to get the kids to play 0, 1, and 2 for rows. I feel like they're just not ready yet. So should we give it a try? See if it works for us? So we probably want to print the board one last time, right? Once this whole thing is done, print board, given the board. That way we see the final result here, right? Now, I don't know if you know this about tic-tac-toe or not. Oops, what happened here? It stopped. Well, not is game over. Uh-oh. Something wrong with our is game over. Something must be wrong with our is game over here because it stopped. But it's impossible to lose a tic-tac-toe if you know what you're doing. You're well aware of that fact? Some people? Okay. So I used to offer, I would tell people, if you can beat me at tic-tac-toe, you get an A in the class. And then I told my wife about that. She's like, that's just mean. I was like, it's not mean. Like, you're just not going to beat me. She's like, well, not everyone might not know that. I was like, oh, okay. So I have to warn you ahead of time. You can't beat me at tic-tac-toe. It's just impossible. But let's see. Okay, so something's wrong with our is game over. So let's run into debug mode and see why. You probably messed something up here. So I got to here and I want to step into. So we're in our is game over function. So we're going to check to see did someone win horizontally. So now I can step for row on the board. Okay, so return false. That's good. That's what we wanted here. And we'll step in again to the next function. So did someone win vertically? Nobody won vertically. Return false. That's good so far. We'll step into the next one. Did someone win diagonally? All right, if it's not a space, step back into, oh my God, I missed it. What did I clicked too many times, I guess. It wasn't the diagonal, was it Cat's game? Couldn't be the Cat's game one. Did we screw this one up? I did. I think I screwed this one up here. So, yep, yeah, our logic here. So this one needs to not, I need one more parenthesis here. Right? Because with the ors, right, it was doing this one first and then or this, and these ones did match because they were spaces. Right? But I have to get this one in here first and it with that. So this is the or, not these first two or this next one. All right, hopefully that'll work in here. There we go. Okay, X's turn. All right, I'll let you guys play first. Where are we going to go? One, okay. 1, 1. All right, my turn. I'm going to take the corner here. Where are you going? Zoom in. I mean, you're not going to beat me. It really doesn't matter. It's okay. I might beat you, though, and that'd be embarrassing for you guys. Yeah, shout it out. 1. Well, 1, 1 you already did. You got the center. You got 1, 1. Right, because we're counting it from zeros.
0, 2.
So row 0, column 2, on 0, 2. All right, well, I got to go here and block you then, so I'm at 2, 0. All right, I stopped you. You got to stop me now. This game is super exciting. I know exactly what's going to happen. 1, 0. Yep. Okay, so now I got to stop you, so I'm at 1, 2. All right, now you can't win. I mean, you could try for either one of these ones, but I'll stop you again. Where are you going? I can't win at this point, but 0, 1. All right, so I got to go 2, 1. I stopped you. 2, 2. Look at that. Cat's game. Go figure. You want to try again? Or is that boring enough?
I'm just curious if someone can actually beat you.
It's literally impossible. It will not happen. The algorithm's not that hard. Like if they go in the center, you go in the corner. If they go in the corner, you go in the center. It's not too hard. And then every move just plays out from there. All right, no one else? That's fine. No worries, no worries. Okay, so we can nest a list. A two-dimensional list is the way I like to think of them here. Now, what gets weird, though, is they don't actually need to all be the same size. Like, this was a nice, easy square here. They don't have to look like that. So let me go, I don't want it at the top here, maybe up here, right? I can make a list of something here. So we'll say items in our pockets is a list here, right? And then we'll have a list of items in each of our pockets here, just for fun. So I have a wallet, and that is it because I took my phone out of my pocket already, right? Who wants to volunteer what's in their pocket?
I don't have anything in my pocket.
Okay, nothing. Okay, sure, that's fine. It could be an empty list here. That's fine. Car keys, okay. Car keys. Oh, let me do car keys. What else?
AirPods.
AirPods. Car keys and AirPods. Change. All right, so sure, for that one here. Oops, that needed an equal sign. That's why it kept going red. Who else has stuff in their pocket? Anyone want to volunteer? Should we go for bag? That's fine. This will work here. So you can have different numbers of items in each list here. It's pretty good. And we can even have like numbers in this one here if we wanted, just because. Like maybe you've got the first 7 numbers in your pocket somehow. Sure. You can print items. It's like if you're going to be on Sesame Street, maybe you need the numbers in your pocket. It's very important for Sesame Street. Right? And it prints out just the same, right? Here's the item, here's the item, here's the item, here's the item, right? So here's the list, here's the list, here's the list. So there's 3 things in the outer list, and each of the inner lists has its own set of values here, right? Whatever it wants to be. So it doesn't have to be perfectly square. You can do all sorts of interesting things with them here when you nest lists. Right? 2-dimensional, look at that. They made tic-tac-toe as well. But they printed it out the slow way. Right? I don't want to have to type that much. I'd rather do a loop, right? Yeah, so just be careful getting at your row and column, right? This little 2D list here is fun. You can say for row index in the row, for column index, the item that's in that column, right? Enumerated the row index, the column index, and the item. Right? I'll give you a nice little printout of each of those items here, which is fun. You can also slice lists. We did slicing with strings. Works basically the same way for us. Right? We get the copy of it here. You can go to negative values. You can start at -3, go to -1, like anything you want. You can do pretty crazy here. You can give it the stride, same way like we do with our strings. It'll get every other character, every third item in the list here. It's lots of fun. And they're optional, right? It's basically the same chart as it was for strings. And then to modify lists here, weird stuff can happen if we're not careful. Again, the best way to modify your list is when you loop through with an index. Or enumerate, because we're grabbing stuff by index, right? You have to change it by index here. If you try and do it with this value here, it's not going to work, right? Because it's just setting the temp value, setting the copy to it here. You can change list size, sure, we can add, subtract to it, that's all fine. List comprehension. So these are the shortcuts here. People love these. Building lists out here, and they're just a little bit awkward to read. It takes a little while here. So similar to the ternary expression, we're doing like 3 things in one in a single line. We're doing the same idea here. So we're saying for the loop variable in something that's iterable, some collection here, here's what I want to do with it, and I'll grab the new list here. So it looks really weird. So we'll do that up here. So we'll say. So here's our numbers then is going to equal, well, give me some numbers to put in the list. Positive or negative? 2, 4, 6, 8. What else? 42. 73. Okay, sure. So I can say this will be like halved numbers. I don't know. Is a list of. Now we're going to build kind of the right-hand side first. So we'll say this is for number in numbers. And what do I want to do with it? Now I do this on the left-hand side. Just like with the ternary expression, it starts with what you want to do. Then you do the if. These are driving me crazy. I can say number, right? This is my variable here, divided by 2. Right? So it's the same way as saying I want a halved numbers list here. Numbers equals a list. And then for number in numbers, I want to take halved numbers. I want to append number divided by 2. Right? Append, there we go. So 3 lines versus 1 line. Again, I think this is easier to read, but people go nuts for these sometimes here. Right? And we can print our halved numbers. And we can print our halved numbers again here. And they should be the same both times for us if we did it right. Right? Yeah. Half of each of those as we went. Worked out pretty nice for us. Right? So expression on the left, your for loop on the right-hand side versus just putting here. And then you get to save the dot append. Right? We saved a whole lot of typing. We feel good about ourselves. Unless, again, you're getting paid by lines of code. Then you do the more verbose one. It's not always like paid by lines of code, but like we look at how productive are people. You're like, oh, you wrote 50 lines of code this week. You didn't do very much work. Oh, you wrote 700 lines of code. You must have done a lot of work. But like, actually have to look at the lines of code, right, and see what happened.
Just put anything and it doesn't work.
Yeah, you can put a bunch of nonsense. The problem with metrics is people will give you what you ask for. So if your metric is lines of code that you're looking at, they will give you lines of code. Right? It's really easy to do those sorts of things here. So people will always play to the metric that you create, which makes it hard to measure software. But again, that's why software engineering managers have jobs and things like that. So okay, so we can do the list comprehensions. Those are fun. Oh goodness, yeah, with the for loop or the equivalent comprehension. So looking at a bunch of different ways you can do it with one-liners. That's super useful here, I'm sure. Take the min of the sum of the row for row in my list. So that's kind of fun. So it gives you the minimum value, right, of the sums of the rows. That's kind of fun. You can do some cool things with them. You can also add if conditions here. So not only can you add on stuff on the left-hand side, you can add on ifs on the right-hand side, because of course these aren't ugly enough already. So let's do like if number modulus 2 is 0. Right? If my number modulus 2 is 0. Right? So only take the halves of even numbers as we go now. Right? So now we took out 73. Right? Again, it's super crazy to try and write these unless you've done a lot of them here, because you're all over the place with your expression and then your for loop and then your if condition. So you can tell I'm not a fan. ChatGPT is a big fan of them, by the way. That's a really easy way for me to see if you use ChatGPT, because it will give you list comprehensions up the wazoo. Because it copied off of what it found online. And things online, they use list comprehensions because people want to look cool online. Like, look, I can do it in 1 line. And then, sure. Do you ever hear the joke? And it's kind of sad here. But like, if you're looking for answers on Stack Overflow, the best way to get an answer, like if you just post the question, someone might come along and answer it, because software engineering is a really cool community and people like give away their time to answer questions for people. But the best way to get an answer is to then make a second account and post the wrong answer, because people will come and correct you very quickly. Because for some reason the community is also a little bit toxic and loves to correct people. Nothing's worse than a wrong answer. So they will quickly give you the right answer by correcting the wrong answer, other than just leaving it out here. It's sort of a sad joke, but it actually does work on Stack Overflow. So, all right, sorting lists. We did sorting already. Man, we're just got a lot of sections today. So we did the .sort method. There's also the sorted. Right, makes a new list without modifying another one. All right, the last bit. We're going to save dictionaries for Wednesday. Is that okay? So I feel like this was a lot already. We'll have some fun in lab. Is command line arguments. There's this sysargv thing. Sounds really crazy here. But if you notice, when we hit run in PyCharm here, it gives us something down here. And if you look at what it's running, it says here, run this Python executable. Here's the name of the Python file here. So this is a command line argument to the Python executable. You can go do this by hand in Windows Terminal if you're so curious to. Let's go see if I can find it here. So let's go CIS 1501. And then chapter 8, no, I don't want 2, chapter 8. Oh, I'm in the wrong folder, that's why. 1501. There we go. Chapter 8. List of dictionaries. All right, so here's my main file here. So I have to tell it where Python is. Now, my computer, depending on how you install Python, you can add a reference to Python. So if you just say Python, mine's not found here. It got installed with the py executable. There's a lot of weird things with Python. Don't worry too much about it here. But your command line stuff it's interesting, and you can get into it eventually. It's probably not worth your time right now. But if I say py, it actually goes and runs this thing that goes and finds Python for me. It's one of the things Python does for you when it installs here. So py will say, oh, here's your Python executable. So I can say py main.py. And it goes and runs my Python file. It says, oh, here's the Python file you want me to run? Sure, I'll feed this to the Python executable. It will go and read your file and do the things you told it to do. You don't need a fancy IDE to do this stuff. At one point, it was a fun exercise to make people go and do this from the command line and use Notepad to write their Python file here. It's really awful, but having done it once is maybe like a rite of passage if you want. So like you can open up Notepad and say print hello world. Just wait till next semester. We'll do a little lab where we use the Unix system. And Unix does not have a pretty little graphical anything anywhere. The only thing you get is this lovely black box, essentially. And we do it all from here because there's a kind of a good reason, I suppose. So one of the things that our accrediting body does, the ABET accredits engineering programs across the higher ed and the area. So when they look at your program and look at all the things that you teach, one of the things ABET says you should teach software engineers is how to use more than one operating system. Because if we only ever taught you Windows, you're probably missing out here, which is probably true. So one of the things we do throughout the program to teach you more than one operating system is in the 200 class or 2001 class, we have you program in Unix. It's terrible. I do not recommend it. But it's really cool and interesting that you can connect into the college's Unix server and make the college Unix server run your Python stuff. So like if you have big, heavy things with lots of computation and you have a small little tiny laptop, you don't have to do all the work on your laptop. You can push it off onto the college Unix server and say, hey, big fat server, you do a bunch of calculations for me here because you have a lot of power. And you can do it really quick versus me trying to run on my puny little laptop. Now, not all laptops are puny, but depending on what sort of size of data and amount of data and processing you're going to work with, that's really cool to be able to distribute the work to other systems. So that's sort of the start of that conversation of how do I make other people's computers do my work, right? The cloud is just other people's computers. Right? You knew that? It's not actually like a magical cloud. It's just someone else's computer. Okay. So that sort of thing. So you can do it with our systems here. You don't have to pay Amazon or Oracle because they also want to sell a cloud, or IBM who wants to sell a cloud, or Microsoft has a decent cloud. Mostly Microsoft or Amazon right now are the big cloud players, but we can do fun things with that. Anyway, so these are command line arguments. So if I wanted here, there's this special sysargv I can go and print out here. So if I just want to print sysargv here, I got to import sys. We'll import sys, and we'll print sys.argv here at the top of my program. Now we'll see for this one here, right? It was main py. This is the full path to it here, all the way in my system here, the full path, not relative here. But from the command line, I can use my relative path here. And I get, hey, the argument here was main.py. That's what I gave it here. I found the name of the file here. But you can give it more than one argument here. And this is where programs get to be interesting here. You can say, hey, like 1.1 didn't actually do anything yet, but we could take that input and use it, say, in our tic-tac-toe game. Right? So you can take command line input here and use it in your program. You don't have to have necessarily the regular inputs that wait for people here. You can give it when the program runs. Now this might not sound very interesting, but you can automatically trigger programs to run and give them arguments based on other things as well. So I can go through and run some sort of automated script and I give it some information here while it runs rather than having someone sit there and type stuff as they enter. Right? So when we get into like the idea of automating things and tasks and scripts, being able to pass command line arguments is super helpful. So we can do a lot more with that from there. Just not anything we're going to do right now. All right, should we do tic-tac-toe one more time and then call it a day and go to lab?
Sure.
Okay. Give it a try.
0, 1.
0, 1. Okay. Oh, you're going to the center. Right. I think for this one I have to go 1, 1. People don't usually play this one on me very often. Where do we go next?
2, 2.
2, 2. Okay. So I have to make sure you can't get to the top right. Right? Because that would let you be able to get 2 different spaces at once here. So I have to go 0, 2 to block you, and now you have to go block me. 2, 0, right? Row 2? Yep, 2, 0. Okay, so I have to go 2, 1 to block you. All right, so your only chance to win is on the left-hand side, and I'll be able to block you. Right? Row 0, row 1.
0.
Well, 0, 1 is where I went, right? That's me. Or, no, that's you already moved there. Try again. You want 0, 0? 0, 1, 0? Yeah. 1, 2. Okay, sure, you can go there. Place your X here. Yeah, I'll go up here because it makes a pretty pattern here. So I'll go 0, 0. And then all you have left is 1, 0. We have a cool looking pattern at least. I get a Y shape for my O's. All right, awesome. So let me, we'll call it a day. We'll get over to lab at 2 o'clock. I'll go get some coffee on the way. Life will be good. And hopefully the room will actually be unlocked today. And the door should work. We'll see. All right, thanks, folks.